Assalamu alaikum. We start the book Electronic Devices by Floyd. The first chapter is Introduction to Electronics. In this chapter, we can read all these key terms, or mostly we read these key terms. The first point is atom. We start there. I highlighted all the main point of the topic atoms, and we describe in the diagram. This is 2D form of the atoms. Atom consists of electron, proton, neutron. Proton and neutron makes the nucleus, while electron move can around the nucleus. And proton is positive charge, neutron has no charge, while electron has negative charge. This model is belong to the Bohr atomic model. There are nearly 118 elements. Every element consists of atoms, while every element has their own structures like that. In this topic, he gives me two examples. First one is hydrogen, second one is helium. Hydrogen consists of one proton, one electron, which balance the atom, and helium consists of two proton, two neutron, and two electrons. This is also balancing the atomic model. Next point is electron and shell, which is subpoint of atoms. In this point, we read about how to divide the electrons in their shells, and this is the periodic table, which is formed by atomic masses. And atomic mass is the proton number of proton in the nucleus or electron in the atoms. And this is the silicon atom atomic structure. Silicon has 14 proton, 14 neutron, and 14 electrons particle. Nucleus consists of proton and neutron, while we divide the electrons in their shells. How we can divide it? See this formula: 2n raised to power 2. N will increase by number of 1, 2, 3, and so on. As 1, then this is the first shell, which has only 2 electrons. If it is 2, then 2 raised to power 2. 4 multiplied by 2 is 8, and this is the 8 electrons in their second shell, and so on. Let's we start it. There is, he mentioned everything. Second 8, third 18, fourth 32. While silicon atom is unstable due to incomplete of their outermost shell. Therefore, he makes bonding. Next point is called the valence electron, and where the valence electron is located, the outermost shell is called the valence shell, and the electron is called the valence electrons. And the outermost shell is uncompleted, therefore it makes a bond with the other atoms, and the electron are less tightly bound as compared to the inner electrons or inner shells of the electrons. When this valence electron become free electron, when it get energy from external source and become free electron, I give the example. When this free electron go to the hydrogen atom, then hydrogen completes its outermost shell. As we know, hydrogen have only one electron, and when he get and completes its outermost shell,
it become hydrogen ion. So there are two type of ion, positive and negative. When hydrogen atom get energy or its valence electron get energy, he release the electron and become negative ion. So in ionization topic there are these are types. Ionization energy are those energy when electron leave the valence shell or enter the valence shell. And this process is called losing of valence electrons is called the ionization energy. Let's see. It gives the chlorine example. We see that. Now the quantum model. So the quantum model, there are 2 points: wave particle duality and uncertainty principle. Wave particles show that the light move in particles like photon, and electron also have these dual characters, which it also wavelength and have a particles. So both have the same type of characters, dual characters, wave and particle. The wave nature of electrons remove because of their neighboring electrons. Their amplification is cancel each others. And uncertain principles. According to the Heisenberg, it is impossible we find the velocity and position of an electrons accurately or accuracy. So we use the uncertainty. We use the probability that in this cloud electron is here, maybe there or there. So the quantum mechanics give us the 3D dimensions of the atomic model, which is very difficult for understanding. For simplicity, the quantum model gives us that the subshells or orbitals. For example, I give the back to the silicon model. Quantum model say that first orbital has only one subshells and second one only one subshell. Second one has two subshells and third one has three subshells. So the energy also divided into their subshells. They have two subshells, so they can divide it. Quantum model use these notation S, P, D, F. S for 2 electrons, P for 6, D for 10 and 14. Let's see how he can use it. These are SPDF and maximum 2 electrons in S orbit, P for 6, D for 10 electrons and F for 14 electrons. Each has divided into their. So the first orbit has only one suborbit or subshells orbitals. This is S. 2 has 2, 2s2 and 2p6. For one for shell, this one for shell and this for our electrons. So this for second shell, first orbital, second shell, 3 electrons. How much electron? 2 electrons, 3 electrons. Okay, this is the example of electronic configuration of nitrogen, which have 7 electrons. Next, he mentioned about the three-dimensional representation of atoms and electronic clouds. Mention about where the electrons may be, but the in atomic Bohr model cannot explain these things. There the example. First we use the example of this, the silicon atom, which have 14 electrons. So he gave how we configure configurations of their electrons like that. We see that there is 2 electrons, 2, 6, 2, 2, and finish. This is the first electron, which have first shell, which have 2 electrons, 2 and 2, and 2 and 6, 8 electrons. Second shell have 8 electrons, so it is completed. Third shell have 18, but it is not completed. Not completed, we have only 4 electron remaining. So we divide in S and P. If it is more electron than 14, then after p shell orbital or subshell completed, there is starting d shells, then f shell. So like that we can configure every element in the periodic table like that.
Okay, next he explained the 3D diagrams of an atoms, like this quantum mechanics. We use the sodium atoms. This is the s orbit, first shell, which represent 1s orbitals and 2 electrons. The second one circle gives us the 2s orbital, which is second orbits like this. And third, these dumbbell like shapes or orbitals are those orbitals which p. So he divided it into x, y, and z. Next, he can divide this big circle into 3 as 3 orbitals. This represented 3s orbital is this one. So this is the 3D diagram of sodium atom, and electron can be maybe in this cloud. This is the cloud, and this is not a circle. These are the spheres, like spheres or spherical shape or dumbbell shape. These are the dumbbell shapes or ellipse, which is like that. I draw it ellipse like that, while S shape has a circle like that. He represented it. Okay, he is maybe like this form. Okay. Okay, next point is measuring materials used in the electronics. Which materials we discuss in this topic? Core of an atom, carbon atom, two type of semiconductors, which two types are semiconductor, conductor, and insulator. Band gap, valence band, conduction band, semiconductor atoms. Silicon, germanium atoms, coolant. These are we discuss below. Let's start it.
Next topic is insulator, conductor, and semiconductor. First, it is explain about the core. What is core? Core is the inside the valence shell, or inside the outermost shell. There he explain everything. That the core consists of inner shells and the nucleus. I indirectly explain it. And he gave the example of carbon atom. Like carbon atom consists of 6 electron, 6 proton in the nucleus. This is nucleus, and this is the first shell, second shell. Second shell is uncompleted, therefore this is called the valence shell. And so the inside of the shell is called the core. And core, if we notice that the core have minus plus 4 charge because it have leave the valence shells. Now we can he indicated about the insulator. That's what he say was then conductor, semiconductors. I explain it in this there. Just a minute. Okay. Insulator. What is insulator? Everybody know that. When current do not pass in any materials, then it is an insulator. We give the high energy to become a conductor because he is Valence electron or tightly bound, and so it becomes an insulator. And there is the example of insulators: rubber, plastic, glass, and other. Next, conductor. Everybody knows that conductor, those material can electricity is passed easily, while insulator is a compound and conductor is a single element like copper, silver, gold, aluminium. Semiconductor. Semiconductor is those materials which are become between the conductor and insulators. In normal condition or normal form. Normal form means intrinsic state or pure state when no impurity can be added into the semiconductor. They are not a good conductor or good insulator. These are the example of semiconductors, and compound semiconductors are these examples. And then we usually mostly silicon as a good conductor semiconductors. Next topic is the band gap. We know about these. I can explain it. First, I draw the diagram. If my diagram is not a good one, this is I mention it a conduction for C, and valence band. Where is it? This is our nucleus. This is our nucleus, and this is the valence electron, outermost shell of the electron. This is first or second, say first or second shells mention about it. Then last shell is called the valence electrons, that valence band which is represented that. And the conduction band. Conduction band are those bands when we move one electron from its valence shells. We move or one electron escape from valence shell. Escape from it. One electron escape from the atoms. It become ion. So this free electron move anywhere. Where is it in the material? This is in the conduction band. So the when electron jump from valence band to the conduction band, it become free electron. Here we explain everything and easily. The conduction band. First of all, conductors. When valence band and conduction band overlap means we use a small amount of energy to give the electrons of outermost shell, like copper, Cu. There are many free electrons because in the material we give one atom a small amount of energy. The electron move to the conduction band and free to move anywhere in the material. When semiconductor, there's some energy gap between valence band and conduction band. This gap is due to this gap we provide some energy, external energy to the electrons to jump from valence band to the conduction band. In third form, the insulator, there are very high amount of energy required for jumping the valence electron to the conduction band to become free. It's very high amount. We explain all these things in this topic in band gap theory. Everything in these topics. And this energy is called band gap energy or band gap theory. Comparison. There is a comparison of semiconductors material and conductor materials. Next point is silicon and germanium. He compared silicon atom has third valence shell while the germanium has fourth valence shell. The third shell is greater amount of energy required as compared to the fourth. Fourth has less amount of energy to remove its electron from their outermost shells. And next is the covalent bond. In covalent bond, how covalent bond is made? By mutual sharing of electron from one silicon atom to the other, like this. The one electron from this atom and one electron from these atoms and share with each other. So the neighboring fourth atoms of the silicon makes its outermost shell complete, like that. And there is also the here its neighboring fourth element complete its outermost shells, like in this crystal form. It shows it that every neighboring atom completes the neighboring atom of the crystal of the valence shell, complete the valence shell of the silicon atoms. Okay.